All right, hello. We're looking at our next part of our circles, which is looking at the relationships of the chord lengths that happen in our circles, as well as tangent lengths with our circles and even secant lengths. So we're going to start off with looking at segments of chords. So for us, if two chords intersect in the inside of a circle, then the product, meaning multiplication, of the parts of one chord is equal to the product of the parts of the other chord. So when we look at the circle we have here with the chord, so this is saying that if we take our first chord, I'm going to go with the longer one. You've got two parts to it. I have a short part here down in the bottom left, and I have a longer side on the upper right. So if we think about that as two separate parts of this chord, so let's call this part A and we'll call the other piece part B. Keep in mind the same idea for the other chord. It is cut into two parts, a longer part and a shorter part. And instead of an A and a B, we'll call these, let's say, C and D. So this whole part is C on the left, this whole part is D on the right. So that property that we have says that the product of the parts of one chord have to equal the product of the parts of the other. So meaning for our formula, my A piece times the B piece has to equal the C piece times the D piece. So again, A and B came from one chord, were the two parts of that first chord. C and D were the two parts of the second. So let's see how that works for our two examples. So solve for X in this first example. So again, you could start with either chord. Let's say I have the 5 can be my part A, the 12 can be my part B. So there's A and there's B. And then we'll do the same thing for the other chord. My X can be part C, my 6 can be part D. So there is my C and D. So the rule says with the formula, A times B has to equal C times D. So let's plug in our pieces. So my A is a 5, my B is a 12, and it's got to equal C, which is X, times D, which is 6. So we have really our equation here that we're going to solve. So 5 times 12, that gives us a 60, which is equal to X times 6, or 6X. So now I can divide the 6 out, and my missing piece, my X, has to have a length of 10 units. So let's try another one that steps it up just a little bit. All right, similar idea. Let's say this time we have 10 will be my A piece, and how about X plus 4 will be the B? And then we'll do the same thing on the other chord. X plus 1 can be C, and 15 can be D. So when we are labeling these, again, it doesn't matter which chord is AB and which chord is CD. What matters, though, is that the A and B from the same chord, C and D from the same chord. So with this, let's look at our next part here. So A times B, so 10 times, oops, sorry, wrong color. So 10 times the B part, which is X plus 4, should equal the C part, which is X plus 1, times D, which is 15. So since now we're multiplying numbers by expressions outside of parentheses, we will need to do the distribution property. So 10 times X, 10 times 4. So 10X plus 40 is going to equal, and same thing for the second piece. Even though my 15 happens to be at the end, it's still the distribution. So 15 times X, so 15X, 15 times 1, so plus 15. And now we can solve this out. So I'm going to start by canceling out the smaller variable first, so minus the 10X to both sides. So my 40 is equal to 5X plus 15. Now we can subtract that 15 from both sides. Sorry, run out of a room. So now 25 will equal the 5X's left. Divide out that 5. And my X is 5. 25 divided by 5. All right. So again, just remember A and B from one chord, C and D from the other. It does not matter, again, if I write A at the bottom and B at the top like we did for this one. You easily could have put B where the 10 is and A where the X plus 4 is. You still get the same answer. Again, only thing that matters, A and B from one chord, C and D from another. So now let's say we have pieces of secants. So now our rule, our property, says if two secants share the same endpoint outside of the circle, then the product of one secant and its external part are equal to the product of the other secant and its external part. So with this one, keep in mind, we're looking at the outside section times the whole length here. So that's basically what we're trying to set up. And again, we're going to use similar parts to what we had before. We're going to cut each part, each secant into pieces like we did with the chords. So let's say the external part can be A of one secant. The same secant, the internal part can be B. And then we'll do the similar idea for the other secant. The outside piece can be my C. The inside part will be my D. Now the A piece and C piece are the external or the outside pieces. So we're going to, again, take those outside pieces times the whole entire secant for both of them. And that product is supposed to be equal. So with our pieces that we have for these sections, we are looking at A times A plus B, because A plus B gives us the whole entire way across. And that should equal the same thing, but for the other secant. So C times C plus D. So again, those two pieces have to be equal. And again, it doesn't matter which secant comes first. What matters is, again, A and B go together. C and D go together. So let's try our examples for this one. So for this example, we're going to, again, solve for X. So we need to find our pieces. So I'm going to start with this piece at the top. My A piece can be outside. The B piece will be inside. So there's my A and my B. Similar idea for C and D. The formula had C on the outside, so C needs to stay on the outside here, even though the lines are pointing to the other side. So there is my C, and there is my D. So let's plug in what we have here. All right, so the formula says take your A, which is my 6, times A plus B, so 6 plus 4. And that should equal the same thing for the other secant. My outside piece C times C plus D, or 5 plus X. And very much like the last example we did, you've got variables, I'm sorry, not variables, you've got constants, numbers outside of these parentheses. So you will have to distribute for both of these sections. So let's do that now. 6 times 6, 36. 6 times 4, 24. Or you can add together the 6 and 4 first in the parentheses and then multiply that by 6. You're still going to get the same value of 60. But for the practice of distribution, that's why I did it that way. And now the other side, 5 times 5, 25, plus 5 times X, 5X. So let's continue with this solve. So I'm going to subtract my 25 to both sides of my equation. So 60 minus 25 gives me 35. And I still have 5X on the right side of my equation. So now divide out that 5. And my X is equal to 7. Let's try another piece that steps it up just a little bit. So it's the same process. My A part has to be outside, my B part inside. And same idea for the other secant. C is outside, D is inside. So there's my C and there's my D. So let's plug this in just like we did the last time and solve this out. So the formula says to start with the outside piece. So that is my 10 times, and then we add the parts up. So 10 plus 2X is equal to, now we do the same thing to C and D. So 9 times 9 plus 2X plus 3. So now let's get ready to kind of clean this up a little bit. So we can go ahead and distribute the beginning. So my 10 times 10, 10 times 2X. So I do have 100 plus 10 times 2 is 20 and the X. But before we distribute to the other side of my equal sign, let's go ahead and combine some terms on the inside of those parentheses first, because it's just a little less for us to multiply and deal with later. So we still have our 9 out front. We'll still keep the 2X, but 9 plus 3 does give us a 12. Now we'll distribute and take care of that. So 10 plus 20X should equal 9 times 2X is an 18X. 9 times 12, 108. Now, side note, if you did distribute that 9 first to all 3 of these pieces inside those parentheses, it's not going to change that final result. You would still get down to that same 18X plus 108. So now let's cancel some pieces out here. Let's start solving. So I'm going to subtract the smaller variable first. So minus the 18X to both sides. So I have 10 plus 2X on the left equals 108 on the right. Now I'm going to leave the 2X alone and subtract my 10. So my 2X equals 98. Now we're going to keep going so I can divide out that 2. And my X is 49. And again, this is a different formula than when we were dealing with the angles and where the vertex of the angles were, because now we're dealing with the physical segment lengths and not the angle measures anymore, or the arc measures. So do not get these formulas mixed up with the previous ones that we've dealt with. All right, let's look at our last property, segments of a secant combined with a tangent. So again, it's very similar. If a secant and a tangent shared the same endpoint outside of the circle, so we're still outside, then the product of one secant and its external part are equal to the square of the tangent length, meaning the square or exponent of 2. So this time I don't have an A and a B and a C and a D. I only have 3 sections this time. So my one segment, my one piece, does not have the other side. So I'm going to have my A piece still, but this one I'm not going to get the B because there's nothing else over there. So I don't have that B piece, but we will still have the 2 pieces of the other secant. So a C section and a D section, or a C part and a D part. So we will still have that. So this time it's our rule says, our formula says that it is the square of the tangent part, so A squared. And that should equal the same setup as the last one. My outside piece times the whole segment, the whole secant, so C plus D. So this part, this section did not change, only the beginning, because we don't have 2 pieces anymore, we need to square it. So let's try this last formula with our last 2 examples. So solve for X. All right, so find the piece that is just one single, and that is my X. So there is my A piece. Again, there is no B for this one because there's only one section to that top secant, that top segment, sorry. But we still have the C and the D. So let's plug this in and see what happens. All right, so the formula says, take your A and square it. So X squared should equal, now we do the other side, C, which is 6, times C plus D. So 6 plus 4. There we go. All right, so we're going to keep your X squared. But let's see what we have on the other side. So again, we can distribute the 6 like we did on the last example, or take care of what's inside the parentheses first. 6 plus 4 gives us a 10. So then we can multiply that 6 and 10 together. So I still have an X squared. Should equal 6 times 10, which is 60. So now to undo that square root, to undo that square, we will have to square root this. So my X will round this off to about 2 decimal points. So my X would be about 7.75 units long. So that's about how long it is. And again, it is rounded, it is approximate. So now let's try another one. All right, so again, the outside piece of the tangent is my A. So this time I will have 10 squared equals, now let's get your 2 parts of the other, a 5 and 3x. So the 5 will be my C, the 3x, the D. Let's plug that in. So we need our 5 first, times that same 5 plus the other piece, 3x. And now let's solve this equation. So 10 squared, 10 times 10 does give us 100. We will distribute this 5 in front. So 5 times 5, 25, plus 5 times 3x, 15x. And now we have our equation that we can solve. So we're going to start by canceling this time the 25. So 75 is equal to 15x. So now we can divide out that 15. And my X is equal to 5. So sometimes, especially with these dealing with an exponent, you might have an answer that is rounded off. Other times you might have nice values like this 5 we just had. So guys, I hope you enjoyed learning a little bit about your secants and tangents and chords and how to find the actual lengths, not the arc measures, not angle measures, the physical lengths. So please don't hesitate to reach out if you have any questions at all. Bye guys.